this segment, we're going to look at two separate standards. NQ1, which requires that our students use units of measure such as linear, area, capacity, rates, and time as a way to understand problems. There are three substandards up underneath NQ1 that we are going to address in this video. The first, students will have to identify, use, and record appropriate units of measure within context, within data displays, and on graphs. In the second substandard, students will have to convert units and rates using dimensional analysis. Now this means they're going to have to convert between English and metric to metric without the conversion factor. And they'll also have to go between English and metric with a conversion factor. In the third substandard, students will have to use units within a multi-step problem and formula. They'll also have to interpret units of input and the resulting units of output. Now, in the second standard that we are going to address, NQ3, students are going to have to choose a level of accuracy appropriate to limitations on measurement when reporting quantities. The task that you are about to view has been modified from the task Solar Radiation by IllustratedMathematics.Org. I have incorporated data from the local region to be more applicable to my students. Let's take a look at the original task and where we can find it, so that way if you like it you can modify it for your own students or use the one that they provide. So here we are at www.illustratedmathematics.org. Now the first thing that you want to do is go down to the content standards. So you're going to scroll down, you'll go to content standards. Once you're here, you're going to scroll down and look by grade level. We're going to choose high school. And then it's going to ask us about conceptual categories. For this standard, you want to choose number and quantity. All right, now it's going to ask us for a domain, and we're going to choose quantities. All right, now that we're in quantities, we're looking at the cluster. The cluster is for reason quantitatively and use units to solve problems. Well, that's what we want our students to do, so let's look at the standards involved in there. Now that we're in our cluster, let's look at the standards involved. All right, to get to the task, we're going to choose QA1. And we're going to scroll down to the task list, and we're going to choose solar radiation. The website gives you the task outlines, the commentary, and different resources in order to modify it to best suit your students. So now let's take a look at the modified task and watch how my students accomplish the standard while using the modified task.
Okay, so I think we could say we have 375 watts. So then we can change.
The modified solar radiation task asks students if it makes sense to exploit solar energy in their area given solar energy data for each month throughout the year in their region. First, students are going to have to use dimensional analysis to convert from metric units to metric units without a conversion factor, which satisfies the standard NQ1 substandard B.
If you're changing it from watts to kilowatts.
Yes.
So your kilowatts
So
needs
the
to be
watts
on the
will cancel
bottom.
out. There's 1,000 watts and 1 kilowatt. So put 375 times 1,000. So we just move 375 right here.
No, you write one again, and then you would move it to the out, like the next step of dimensional analysis. You'd put 375 right there over 1,000, because you still have to multiply them two. Because if there was 2,000 watts and 2 kilowatts, then you have to multiply that by 2 and put that there.
So I put the 1 right here.
Yes.
375 right here.
Mm-hmm. And 1,000.
1,000 right here.
Right. That's 100.
Oh,
And then you do,
1,000.
then you get your answer.
which would be 0.375.
As you notice, my students struggled greatly with this task, and that's okay because this task was designed to incorporate the standard for mathematical practice, make sense of problems, and persevere in solving them. So it's up to us as the teacher to allow ample time for all students to struggle with the task, and then differentiate to keep our advanced students challenged during the work time and also come in when needed. So now that we've watched students satisfy standard NQ1B using dimensional analysis and converting from metric to metric without a conversion factor, now we're going to watch students satisfy NQ1 substandard C. In this standard, they're going to have to use units within a multi-step problem and also interpret units of input and output. In the case of this task, the input is going to be hours, which is the time, and the output is watts per meter squared.
375 is a kilowatt, and then the hour is 11, and then over meter squared.
Yeah. So for a certain amount of meters squared, you get however many.
It'd be 4.125
over meters squared per day in January. But that's 425 watts. So when you put that,
kilowatts an hour.
yeah,
Kilowatts
I got you.
times hours over meter squared. So that this one will be
So wouldn't it be 4.125 over meter squared? Because that's kilowatts per hour. Per kilowatt. I'm just saying how to write it.
Yeah, I see what you're saying. Because
We figured
we
that
solved the
out.
other one.
Yeah, on top of that. And then I think it's saying you take however.
I don't know, because this would be just the unit. This is the unit, and we just plug
we
plug
plug
that
that in.
into the equation. But
So
we're
you
just,
wouldn't have to rewrite it, would you?
yeah, because we're just using this as a unit.
In order to wrap up NQ1, students must satisfy Substandard A. This tells us that they must identify, use, and record appropriate units of measure within context, within the data displays, and on graphs. Well, students demonstrated that they can identify, use, and record appropriate units of measure within the context in their dimensional analysis as you saw previously, and that is recorded in the table. Students will now use their information recorded in their data display as pictured in order to identify the appropriate units used on the X and Y axis in their graph. They'll use their findings in the data display and record them on the graph. And lastly, they will use their graph to analyze information, such as the month with the largest amount of solar energy.
And then March is 5.
Go ahead and fill that out with the other
Oh,
one
all
so
the
it
way-
won't be confusing.
All the way up.
Yeah,
4.75.
75. Well, all of those are in decimal places, and it'd be easier to estimate if you were being more specific with how close they are. That every cube upward is a quarter.
And then we started at 3.75.
Because our lowest number was 3.93.
In the last clip, students were rounding their findings in the data display in order to meet the appropriate level of accuracy required by the limitations of their scale. Determining that they must round to the nearest hundredth for each month in order to match the 0.25 scale for their y-axis satisfies our last standard in Q3, which says choose a level of accuracy appropriate to limitations on measurement when reporting. Our students have now met all of our standards. Let's fast forward and hear their analysis. So what are the benefits of this graph and displaying this information?
Well, it can show what time of the year is the most successful.
Okay,
What
so
time?
the most solar energy coming.
Mm-hmm.
All right, what month is that so far that we're looking at?
May.
We have broken down both standards using the modified solar radiation task. So the last thing that the students must do is complete the task by answering the proposed question. They'll use the standard for mathematical practice, reason abstractly and quantitatively, in order to answer the question proposed. The proposed question in the task is relevant and realistic to the students, and students must provide mathematical reasoning for their conjecture. So let's wrap it up as we listen to our students answer the question. Does it make sense to exploit solar energy in their area?
Well, it says if it receives 9, it does, but then it says if it receives only 2, it doesn't. But it receives between 9 and 2.
Okay,
So
so what does that mean to you?
I mean, it's pretty much about halfway yes and no.
because it doesn't say anything about less than 9, it just says 2. If it receives only 2, it's not worth it. It doesn't make sense if it only receives 2, but it makes sense if it receives 9. But it doesn't say anything about the amount in between 2 and 9.
Okay, so, well, someone came up to you and asked you what your opinion would be, should they install solar energy into their household, or what would you say to them? Like, what would your recommendation be?
I think it should be no, because it says it makes sense for an area that receives 9, and although it doesn't say anything about less than 922, it does say it makes sense and for if it receives 9 or more. So I would say no, because it only receives 5.
And it's 5 is closer to 2.